I hope people join. Yes, Girish, Kapil, Pranav, Ritika, Jarna, everyone join. Okay, so let's get started. So till now we have seen the tree and I was about to start the trees iterations, right? Once the trees iteration will be done, then we'll start taking up the questions. So let's understand what is in order, pre-order and post-order. Don't go by the name. As I said, as I said, with recursion, we'll need to understand it, how to print it. So let's take a tree. In last class, I think we have taken a structure of it, how the structure is getting created, and we are taking a binary tree right now. Okay. Now, in how many ways it can be printed? As I said, the first methodology that I'll take is something like this. D, B, okay, E, C, F, and A. So what I'm doing is, actually, if you see, whenever in a linked list anything is passed, we will be passed a head node. In this, you will be passed a root node. So first I'm going towards the roots left. So I'm giving the first priority to the roots left. Then it's higher node. And then it's right? No. Then it's right node. So if you see over here, first I'm giving the priority to E. Then the priority to F. Sorry, I'm giving over here C. Then the parent node is getting a priority. So what is parent node? So parents left I'm printing first. So parent node is its parent. So I'll say vertex. So this is left, this is vertex, and right side, whichever the node will be, that is right side. So if I print in LVR form, then it will be printed like this. Now how LVR will be coded, and then we'll understand how recursively it is getting implemented. So I'm just writing a pseudocode, something like print LVR. Okay, what we will get is node root. Okay, or node root. This is in C++, this is in Java. Because over here you'll get a sub object, over here you'll get a structure. Now, what is the first priority we are giving? To the left. So I'll iterate the same function LVR with the roots left.
Be, DBAEC, right? Like DBAEC.
Yes. A should be before. By mistake I written it. Yeah. Yes. Now, can it happen that over here roots left, and whenever I'm passing roots left, it is null? Can it happen? So let's say your root node you're passing as in a D. So D's left is not there. Correct? So when D's left is not there, what I have to do? I have to return to my parent function where it is getting called. Right? So I'll check over here if not root or root is equal to null, return as it is. Don't do anything and return. So rest of the function, rest of the lines will not get printed and it will return. Okay, now once it is reached to the left, okay, so what will happen? Okay, let me write it down and then we will see. See out roots data and then print LVR roots right. Now let's understand how it will happen. So first of all, initially I passed root equal to A. Root equal to A. Okay, so data is stored root equal to A. Now, if root is null, no, root is not null. So it will call again the same function, print LVR roots left. So when a subroutine call is made, subroutine call in the sense, when from any normal program, another function's call came, either it can be the same function or it can be other function. What will happen? Whatever existing thing which are going on, it will be printed, it will be put it into the stack. Line number 1, 2, I'll say 3 and 4. So 1 is executed and 2 is also executed, 3 and 4 are pending. I'll mark it like that. Okay, now here root was left, sorry, root was A, and again the same function was called. At that time, what is root? At that time, root is B. Now here, if root is null, no. Print LVR roots left. So again, 1 and 2 are done, 3 and 4 are pending. And it will call for the next. Root equal to D. 1 and 2 again will be done, 3 and 4 are pending. And it will call for roots left. Roots left is, D's left is null, because now root is D. So D's left is null. So print LVR node will be null. If root null, yes, return. So what will happen when it will get called root equal to null? Over here it will check that 1 itself is calling to return. It will return to its previous calling function. And this entry will be removed from the stack. Internally this thing happens. So now compiler will execute this task. So where we were at the last, 1 and 2 was done, 3 was pending. So what is 3 line? See out roots data, print the roots data, D is printed. Once it is printed, it will go for the roots right, 4th line number. What is 4th line number? Roots right. Do we have roots right? No. So again, this empty entry will get created. It is null. It will come back. And 4th entry is also completed. 4th line number is also completed. That's why this also will be removed from the stack, from the compiler's stack, inbuilt stack. Once it will done, it will again come back to B. And for 3 and 4, again the same operation happen. It will print B and it will come back to root A. So this is what internally happens that I'm explaining, so that you understand how recursion works. And then onwards, whenever we take a question, whenever we take any interview question, you can understand in which way we have to write a recursion function. That's why. Now when it comes to root A, it will first print it. 3rd line over, 4th line was pending, roots right. So again, roots right is what? Root equal to C. And for C, 1 and 2 it will print, and 3 and 4 are pending. So 1 and 2, 1 is roots null, no. Print LVR, again the left. E will be there, 1 and 2, 3 and 4. 1 is done, 2, again it's done, null entry, which will return it back to E. 3, print 3. So E will be printed. 4 is also null. It will go for the it will go for the 4th line, which is also null. Create a null entry and return back. I would like everyone to mute themselves. Okay. So once E is done, this entry will be evacuated from the stack again. And the call will come to C. So at C, 2nd line was done, 3rd line was pending, 3rd line will print it. And it will go for the 4. 4 is roots right. So roots right was what? F. So for F, again 1, 2, 3 and 4 are pending. 1 is done, 2, left is also done, entry, come back, 3, print it. Go back, roots right, F's right is null. Again, it will create an empty entry and come back, and this entry will be evacuated from the stack and will come back here. Here, there is no next line number pending. 1, 2, 3, 4, all are done. This will also get evacuated from the stack. It will come here. Root A, for A, 3 and 4, all lines are done. All lines are done. 4th line was for the right side. Right side was C, E, F. So that is also done. So this also will be evacuated and your program will terminate. Then your program will terminate from here. And then it will output this. So in this way, LVR is getting printed. Now, if I say you have to print it RVL, you can do it, right? Or if I say VLR or VRL, you can do it. That is as simple as possible. Correct? You just have to change the order. This
Dhaval, what is the complexity, time and space complexity of this one?
yes. This is L, this is V, and this is R. Now, if you see over here, each and every node is accessed how many times? Once only. It is going into the stack once, okay, and it is coming out of the stack once. So we are just accessing every node once only. Correct. So when each and every, so let's say there are n number of nodes and they all are getting accessed n times only. That's why it is called order of n time complexity. And if you say at the end it will be empty, at the end it will be empty, and perfectly if you see, every time half of the linked list, or sorry, half of the tree only will be into stack, either the left half or right half, if you would have seen it. But in general, we don't say it's order of n by 2 space complexity. It's always order of n. And why is it so? In a worst case, it may happen that you are showing the tree such like this, which is called a skewed tree. So in this kind of cases, the whole stack will be full with order of n. So that's why we say that for any binary tree, LVR, in order traversal, is order of n. Time complexity, order of n, space complexity. Space complexity is by default with the recursion. With the recursion, it comes by default. Correct? So this was the simplest pre-order. The same way you can think about post-order or in-order. Correct. Now, let's understand what kind of interview questions which can come from this. So before that, I would like to take one more iteration, which is this. What if I want to print like this? A, B, C, D, E, F, G, which is like breadthwise. Then how will I do it?
We use a queue instead of stack.
Why queue and why not stack?
We use queue because due to the order, because we are it's like first in first out, so like it's like a that is why we are using queue.
Okay. So there is let me tell you in this way. So there is a kind of what we can say characteristic that we see.
Dhaval, sorry to interrupt you. What is the expected output? Can you write that as well? I missed that.
Yeah. Yes. A, B, C, D, E, F, and G. Okay. So what here is I'm accessing the node depth wise. So first depth A, then second depth B and C. At level 0, it is A. At level 1, it is B and C. At level 2, it is D, E, F, and G. So the one approach which came from Pranav, I think, is we can use queue. And why is it so? When we are getting a root, we first put it into the queue. So queue can be expressed over here as this. A, I have put it into the queue. Now I want left side element first and then right side. So A's left and right, I'll put it into the queue again. Once this part is done, just put it into the queue. I'll start iterating the queue. Or before that, I can start in this way. I'll just put A element into the queue. Okay. First, I'll take this element A out of the queue and say A is my output. I'm printing it. So A is out of the queue. Now it's left and right. So I'm putting a node over here. Or so B first, C, second. Now, once A's operations are done, what I'll do, I'll start B's operation to take. Print B, and B's left right to push it into the queue.
Dhaval,
Then take out the C and its left and right to push it into the queue.
Dhaval, I'm sorry.
Yes.
I was losing you a little, and I then noticed your Wi-Fi signal. Your Wi-Fi signal is a little fluctuating. Maybe I don't know whether it is at my end or here. Is everybody else able to hear Dhaval clearly?
I think you were breaking out, Dhaval. So I was also feeling the same. Okay, but I was able to get you what you were trying to express.
Okay. Maybe intermittent issue, Kapil. Let's.
Okay, I hope it works now. Yeah.
So,
But your signal is still looking weak.
E, F, and G were getting processed. Now, it's just my thought that can't we use stack? Okay, so let's see, can we use a stack or not? So let's say I'm pushing A into the stack 1, and then B and C I'm pushing into the stack. Now in a stack, what will happen is first node which will come out of the stack is C. Correct. So let's say first I printed A and then it's left and right I'm pushing into the stack. Then output is coming B and C. But we want, sorry, C and B. But we want B and C. Correct. But we want B and C. So can we do something like this, that I push A into the stack and then insert C and B. So what I'm doing is I'm taking a node, just a logic I'm writing, push into stack 1, it's right first and then left. First it is done. Now I'll take out the B and print a B. Now once it is taken out, it's right and left I have to push it into the stack with this logic. So E and F. Now which node will, sorry, D and E, E and D. Now which node will get printed first? D. So I'm printing something like this, A, B and D, which is wrong. So where it was going wrong, B and C was correct step, but pushing E and F or E and D was wrong step. So can I use another stack for that or another data structure for that? Let's say in a stack 2, I'm pushing E and then D, let's say. Okay, then my B is done. Until my stack 1 is not empty, I'll proceed it. Then the turn comes of C. Then the turn comes of C. So C, I'll print it. And then it's left and right. I'll push it into the stack. So its left is G and then its right is F. This stack is over. Now I'll start processing this stack. First node is F. So I'm printing like this, A, B, C, F, G. Again, there is wrong thing. Again, there is a wrong thing. What was the issue? I should iterate from D and not from this one. Correct. But as there is no other way that we can proceed it, yes, there can be other way that again I use another issue, another thing, something like that. Instead of right and left in S2, I push it left and right, then it would be some helpful to me if it would be in S2 something like this, D, E, F and G. Now instead of this, if I would have used Q, then it would help me D, E, F, G. Correct, no issues. But will this approach can help me in printing this tree in a zigzag manner? Now what is zigzag manner? A, B, C, D, E, let's say F, G, H I J K L M N O. So accidentally I found it out that using two stack can help me printing into zigzag. Now at C, if I'm printing something like this left and right, then I would have G and F in a stack 2, and at B, D, E and D. So how will I print now? G, F, E and D. So I would have printed G, F, E and D. Now G's son in the sense right and left children, that I would push it into stack 1. So in stack 1, G's right and left children would have come again into stack. So that would be N, O, and so on. Now, will it help me? Let's understand. So I'm printing like this: A, B, C, G, F, E, and D. And from D, it should start in this way: H, I, J, K, L, M, N, O. Correct. Now, tell me, will it help me to print like this with two stacks? Up to C, it was clear. Up to C and F and G, it was clear. But for rest of the nodes, will it help me, or do I have to change something in my logic? So this was the first question, normal one. Print, sorry, what is happening?
Can we reverse the stack actually? Second stack if we reverse.
Then, just a minute. My pen. Okay. If we reverse a stack, what will happen? Unnecessary, we have to do again and again the processing.
Yeah.
Correct. Now, what I'll do is, we can do it. Okay, but see over here, if I, what I'm doing is, just a minute, I'm taking this stack 2 in just below that, so that we can understand what we are going to access and how. Okay.
Or we can swap the pair.
No. Just think about it. So at while I'm processing C, once the C is over, okay, what I said that in S2 it will go into the left and right. From S1 it is going right and left. In S2 it is going left and right. So in B, what will go? For B, left is D and then E. Correct? So I'm just writing it down over here. D, then E, then F, and then G. Correct. Now, in stack 1, when I'm processing G is printed. Now it's right and left. I'll put it into the stack. Left and right. In S1 it is a right and left. So right side is O. And then N. Then F's, M and L. Then G, E's. E's are K and J. And then D. D's are I and H. I and H. Once this stack 2 is over, I'll start processing stack 1. First H. H right and left. No, for H side, it should be H, I, J, K, L. So this side, when I'm processing stack 1, so these are into stack 1, these are into stack 2, these are into stack 1. This was initially into stack 1, or any stack, it is fine. Stack 2, even if you put, it is fine with me. Okay, so now what it is happening? Stack 1, so it's stack 1 to stack 2, it is going left and right should go, but all are null. So I'll print it and then I'll remove it from the stack. So how it will get printed? A, B, C, G, F, E, D, H, I, J, K, L, M, N, O. Is it giving me the zigzag the same, the way I wanted? A, B, C, G, E, GFEDHIJKLMNO. So this was the logic which we found it out that with using toStack, we can print in order of breadth first search only, but in zigzag. So now if we understand why we were using queue and why not stack, then we can understand that in which way zigzag will get printed. So now if this approach is clear to you guys, can we quickly write down the code for that? First of all, let's understand what are the things are required and then we'll start writing the code. Is it fine? Or it is still not clear?
It's clear.
Clear? Ritika said clear. Kapil, Girish, Durairaj?
Yeah, okay. So basically, we are trying to achieve, tree traversal breadth first BFS, right? That is what we have to do.
Yes, but in zigzag.
A zigzag manner, so that we can achieve in, big of n. So
Big
that is the
of
reason.
n.
Yeah.
Yes. Zarna, clear? Okay. So let's understand what are the requirements. So our requirement is two stacks. First step was push root into stack 2. Okay. Then while stack 2 is not empty, pop and push its all the elements, push its. Which are the things I have to push it into stack 1? Right side and then left side. Push its right and left node into stack 1. Once this while loop is over, I have to write another while loop. While stack 1 is not empty, I have to process the same. Pop and push its left and right nodes into stack 2. Once both the stacks are empty, I need to over. Once both S1 and S2 are empty, return. Okay, and whatever is the output, that is zigzag. That is zigzag traversal of a tree. So let's start writing the code. We need two while loops first of all, so let's write it down that. Okay, while stack 1 is not empty, what we have to do is we have to take out the node. So let's say struct node temp, node star temp equal to stack1 dot pop. First we took it out. Okay, see out temps data. First of all, it's data I'm printing. Then, sorry, first of all, stack 2 is there. Okay, and stack 2. Then what I have to do, S1 dot push temps right and left. Right, S1 dot push temps left. This is over. No, I have to pop the element as well. S2 dot pop. So this temp element is removed. Now same while loop, I'll write it down for over here for S1. I think I don't no need to write it down, but still I'll write it down. Fatapat.
Do we also need a parent while loop, because once
Yes.
When the second loop is executed, the S2 is again populated. So we need to go back
Yes.
to the earlier
Yes,
one.
exactly. That's why only I've started like this, and I just wanted to explain why it is required. Okay.
Or maybe with recursion, this might simplify it a little. I don't know.
No. In which way with the recursion you will use it?
No, I don't know. I was just making a guess
Ha.
because
No. Ha. So what will happen is recursively, whenever you'll go into one direction. See, because
we can send a flag or something and say that okay, if this time if this is the flag, then maybe
ha.
that.
So yeah, I completely agree. But in that also, what will happen? I'll explain you. Okay. I'll keep this point into mind, and then we'll explain this part.
Yeah, no problem.
Yes. Temps left. Okay, and S2 dot push. Temps right. And S2 dot pop. S1 dot pop. Now, as he said, Kapil said, that was correct, that two whiles loop are completed. That will just run this stack 1 and stack 2 once. But we need to do until both are empty. Because see, if this over here, stack 2 was empty and everything, matlab, every nodes, G, F, E, and D's node and its children were pushed into stack 1. Now, stack 1's each node's children should have been pushed to stack 2. But as it doesn't have, then only then we'll stop. So when stack 1 and stack 2 are empty, then only then we should stop. So this both while loop should continue forever until stack 1 dot empty is true and stack 2 dot empty is true. Until that time, both the while loop should continue forever. Correct. And over here, I can define the stack 1 and stack 2 and so on. And this function, I can pass the root node. Correct. So in this way, the zigzag traversal will be required. Correct. Everyone understood the code? So this both while loops are one after another.
Once we pop the element from S1, then should we print it directly, or we have to?
No,
we
printed, right? So let's say
once we pop from the S2, okay.
So see, I'm not even before popping out the element, I'm just printing it, and then I'm pushing its elements to another stack, and then I'm removing the element from the stack.
Okay.
So I explained over here in which way it will happen.
Yes.
So let's say in a stack 2, you have A. Then in stack 1, you'll print first A, and then C and B you'll put it into stack 1. Now stack 2 is empty. Now stack 1's while loop will get started printing this one. So in this also what I'll do, I'll take out B, print it, and then its children I'll put it into stack 2 again, which is E and D. And then C I'll print, and then its children G and F I'll put it into stack 2. Once stack 1 is empty, stack 2 again I'll start in this manner. Correct. So this will go on until both are empty.
Okay.
So now can you convert this logic into code, whichever the language is suitable with you, C++ or Java. So pseudocode I have written, which is completely working in C++, but you need to convert properly with the pointers and all that things. And I hope previously we have taken all the things. Or you think I should write once a tree's code so that you get comfortable?
Maybe we can try this next code anyways you will explain, right? Maybe
Yes. Yes.
So in this session you write one tree code, we will try this out.
Sure.
Not this one. This one is very
easy. This one is very easy. Yeah. Now let's get back to the question. Sorry. That why the recursion is not useful over here. Now what happens with a recursion, that first line we need to print it, and if we use the similar fashion with the recursion, with a flag, let's say I'm using this, and with the flag I'm using this, what I need to do is over here my flag should be 0. Let's say over here my flag is 1. Over here my flag is 0 again, and over here my flag is 1. So now let's try to understand whether it will help me or not. So let's say I'm writing a function print zigzag with a node root and with integer. So over here node star root and integer flag. Okay, now we are doing the same thing. When flag is 0, okay, initially if the flag is 0, if flag is equal to 0, we are pushing this root into stack 2. Okay, or let's say we are writing a simple function in which, let's say this is a normal one. Okay, let me just explain in this way. So this is just a simple function without flag. Okay, and I'm not writing this thing also. I'll explain in which way I'm trying to write it down. So let's say print zigzag function, you are passing just a root. Now what you are doing is, if not root, you are returning. That means if tree is itself is null, you are returning. Now if not, print zigzag utility function, and to that you are passing root and 0. Now what print zigzag utility function is doing, print zigzag util, in which you have root and flag. Now based upon flag you will take a decision. Now again over here you will take if not root, return. Okay, now if you see if flag, so if flag is equal to 0, we need to push this element into stack 2. So s2 dot push root. Okay, s2 dot push root and s1 dot push. Okay, let's say we are not pushing them as well. We are just right now explaining that in which way it will be pushed. S1 dot push root. Okay, so if not flag into S2, otherwise into S1, and we are coming it out. Somewhere we'll print it as well. Now in which way the stack trace will happen? First in stack 2, your A is getting printed because initially your root is null. So in your stack 2, A you have pushed it. Okay, now once S2 is pushed, again you are writing a function over here. Let's say print zigzag. Let's say print zigzag utility with roots right and left with flag 1. So what will happen? First of all, right and then left. What will happen? The same function will call with roots, root equal to C and then root equal to B. So when it will call for C, what will happen over here? It will push C1 in stack 1 C. Now when it is printing for C, before coming for B, when it is iterating for root, okay, let me write it down proper code itself so that it is more intuitive. This code I'm removing. Sorry. This code I'm removing. This part as well. Let's write it down over here. If not flag s2 dot push root, okay, and then print zigzag util roots right with not flag. Okay, so whatever the flag is 0, then it will pass 1 1, then 0, because flag is a boolean variable. Okay, I'm taking it as a boolean variable. Okay, and also print zigzag util as roots left, not flag, because they both will be in the same level. Okay, now this will over. Else part s1 dot push, or even if it is not required, this s1 and s2, it is fine with me. What I'm doing is print zigzag util roots left with again not flag and okay, with flag, and print zigzag util roots light with flag. Now what will happen over here? When I passed with a flag equal to 0, it is again calling. So in a stack internally, okay, in a memory is a stack, a is pushed. Now it's right and left, C will push. Now this line, when this line will get executed, so this is, let's say, first line, this is second line, and this is third line. The same way, this is fourth line, and this is fifth line. Now what will happen? It will come to first. If not flag, yes, for A, print zigzag util roots right C. So for C, it will print. Now for C, again, it will start printing. If not root, return, no. If not flag, because you have passed it not flag, it will go. So initially flag was 0. Now you will pass flag equal to 1. Correct. So again, it will go into else part and it will push what? Roots left. So for C, it will push F and G. So it will print, or it will push into stack something like this: A, C, F, and M. Once it is done, it will print it M, C, F, and then it will print G, N, and O. And then it will come to L. So in this way, it will get done. Sorry, M, F, L, then C, then G, N, O, and then come back over here. So in this way, it will get printed. So even if you write any kind of code, zigzag will not be possible with just one stack, because internally with recursion as well, this is the reason. Internally with recursion as well, it will only use one stack. Correct. And now you understood why it will print like that: A to C, C to A to C, C to F, F to L, M, and in that way. And why not this way? Because this both line are parked into stack. For C and for B, C is done for the stack, B is still pending to execute into stack. And that's why it will not serve our purpose. We need both of them to complete. Correct. So in this kind of code will not help us. Is it solving your doubt?
Yeah, clearly.
Okay. Now let's.
It was just. I think it is important for us to understand more in terms of, when we think recursion.
Yes. So with more number of questions, it will be taken with more clarity.
Okay.
Okay. So if the zigzag part was clear, okay, and why the two stacks are done, okay, and also the code, I can take it up. Next simple question of a tree iteration only, in which you have to print the right view of a binary tree. Now, what is right view of a binary tree? Let's say your binary tree is something like this: C, D, E, F, and let's say G, and let's say H. Then if you see from the right side, which are the nodes visible? A, C, F, and G. Now if you have to print it, how will you print it? Any random thought which is coming into your mind, you can speak up so that we can create our logic from it.
And if H had a child, either left or right, it should be printed as well. That would also be visible.
Who?
If H has
Yes.
a left or a right child.
So let's say H has I and J. Then J is visible from right side, right?
Okay.
Not I. I will be hidden by J.
Okay. Clear.
And let's say F has child, let's say K. Then K will be visible, not G, because G is hidden by K.
Right
From
mode,
each level and
right
find
mode.
the inner element from the left side to.
Durairaj, your internet is slow, I think. We are not able to hear you. You can message as well.
Okay.
If it is not clear, you can try again, but if it is not clear.
Here, like in each step, we are just returning the rightmost node, right? So, like whatever.
In a no, not it is not rightmost node. Let's say if there is no k,
Okay.
then G is your output.
Yeah. So it is the rightmost node, right? At that moment.
Rightmost node of a tree, or you can
Yeah.
say at each level.
Yeah. At
We
each
can
level.
say
Yeah.
something like at each level, whichever is a first node into the right side, that I'm printing.
Yeah. Right.
Yes, your guess is now correct. Now we can think in which way the recursion should be useful. Okay, such that it is useful. Recursion or any of the previous data structures, in which way it can be useful, that we can see. Now, if you see, when we are printing with a queue, okay, when we are printing with a queue, will that help me? So in which way we were printing with the queue? First of all, because see, over here, what we are doing is, we are doing the same thing. We are going through a depth wise, and in depth, whichever is the first node to the rightmost side, that is what I'm printing. Correct. So putting into the queue, will it help me? So let's say I'm putting something like this. So this is, let's say, my queue. So I'm taking A, pushing into this queue A, and A is alone, so I'll print it A. Okay. Now I'll remove the A. I'm just guessing it because right side is my priority. I'm pushing right side node first, C, and then left side node, B. Now as C and B are there, I know that C and B both are at level 1. So let's say this is level 0, this is level 1, this is level 2, this is level 3, this is level 4. Then I understood that which is the first node, C. So I'll take it out and print the C. So until now it is correct. But C's right side node, should I put it into the queue? Let's say if I'm putting it, then with the same logic that all the nodes in a queue are at same level, I was thinking is wrong. B and F are not at same level. Then keeping track of level is something I have to take care of it. Now let's say, okay, now any idea is coming, how can I keep the track of level?
Like, can we use a hash map here to store the levels?
Yes, I can use the hash map, but will it help me? In which way hash map will help me? It
Like
can.
while copying out the node from the queue, like while removing, we can check if what level is that actually.
Okay. Can I use something else? Because see, B is okay. You can use it. So B is at level 1, and F is at level 2 because it's level 1 nodes right hand side. So C was also at level 1. So I need this information of a level along with the nodes.
Yeah.
So if I store it into hash, it may be useful to me. Correct. It may be useful to me. So when I'm pushing C, when I'm processing C, it's right hand side node. Okay, it's right hand side node. I'm putting into the queue with higher
Level. Yeah.
level. So let's say I pushed it. Now I'll take it out to B. Now for one level, have I printed C? Yes. So I need reverse mapping as well, that for 0 level, A has been printed. For one level, C has been printed. For one level B, I don't have to print it. So B's level is 1. For one level node is already printed. I don't have to print it. Process its node, E and D. So E and D will be processed into the queue. Now I'll take out the F. F's level is 2. So for 2 level, any node has been done? No. So for 2 level, print the F. So I'm printing A, C, F, which is correct. Okay, now I'll start processing F's node. F's node is, let's say there is no K. F's node is not K. So I'll take it out from the queue. E. E's node is, E's level is 2. So initially I have to create this hash map. That is now one more task. One time I have to iterate and create the hash map ready-made for me. Now, E's level is 2. For 2, F is already printed, no need to print, process its node. So now my queue is D and G. Now I'll start processing D. D's node is at level 2. That's why I'll not print it because at 2 F is already printed. Now I'll process next nodes. G. G is no need to process because G doesn't have any kids. Then I'll process D's node H, which is pushed.
Like here we also need to keep track if it
Yes.
is already been printed. Like the
So
level
that's why I said reverse also we need to do, and front forward it's also do. We need to keep a stack or hash map of node to level, and at the same level which node is printed.
Yeah,
Correct. Which node is printed, that also we need to keep a track of. That for 2 it is printed, for 1 it is printed, for 0 it is printed. Now when G's turn will come, G's node is at third level. So at third level nothing is printed, so G also will print it. Something like that.
Yeah, we can use a hash set to put these numbers like this.
Yes, we can use it, but the thing is that how much extra space it is getting utilized. We are using one hash for this, second hash for this, one queue for this. 3 times extra space we are using. So my point is, with this approach, with our logic, which we had from our previous question, it is getting useful, but just the thing is, it is having extra space. Now, is it clear for you guys to understand this code? Or not code, this approach. This is not a better approach, so we'll not code it. But first of all, this approach is clear. I need affirmation from everyone. Otherwise, I'll explain again. No issues if anyone has a doubt.
No, it's
Clear?
yeah.
Okay, Ritika said clear, I think. Kapil, Shifra, Girish.
It is not clear to me, Dhaval, this Kapil.
Okay, Kapil. What about Zarna? I think Zarna is...
I'm clear with this approach.
Okay, you are clear. I think Kapil, Girish. I'll explain once again. Okay, the approach in which... So, okay, Kapil, were you following the previous approach in which we were printing into depth first search? A, then B, then C, then D, E, F, H, G, and IJ. When we were printing level wise with a queue, was that approach understood by you?
No, actually, I got a little confused there as well. So I was not sure whether we are using Q or is that something that we are trying and we will look
No, we are using Q. We are not trying. We are using Q itself.
So that was not clear at that time to me.
You should have asked me at that time. Let me just once again, let me just reiterate it.
Well, I have one more idea. Like while storing in the queue, can we store some custom struct where we can like add more information about the label while storing in
Yes, we can have it. That will reduce our extra hash map. Let's say you are storing this information that this node is at which level. Then this hash map will not be required, but still this hash map will be required. And still our order of size, space, complexity will be 2n.
Okay.
Right? Because this hash map and this hash map will be required. I'll come back to this point, but still. Correct? Okay. Let me explain, Kapil, this approach so that we can discuss on the previous approach. Okay. So Kapil, what we have to do is we have to print it. Everyone, it's just a depth first search approach, breadth first search approach, previous approach. A, then I have to print B and C, and then I have to print D, E, F. So what I used a queue. First I pushed A node, Kapil. Then its left and right into queue. B and C into Q. Now A is printed and then B and C were pushed into the Q. Now the B will be printed and B's left child and right child will be pushed into Q. Right now it's left only, so we are pushing left.
So in a queue, when we push an item, that is the first item that comes out.
Yes.
So can we use? So here, like, can we represent that queue in such a way that from where the tail is or where the head is, so that it is more clear?
There it is a tail, and here it is a head.
Okay,
It
and
is
tail.
always, or it is always the nomenclature that this side is a head, this side is a tail, and in a stack it is something like this.
Yes,
Here you insert and here you pop out.
right. So tail is where we will insert.
Yes.
Okay, and head will take out. Okay.
Yes. Okay. Then again we'll process C's node, which is E and F. So first we'll print it, and then it's right and left we are pushing into the stack queue. So first E will go and then F will go. Now again the D's turn will come, and D, E, F in this way only it will get processed. No child, nothing will get inserted into the queue. Now I was thinking, as it is printing into level order wise with the help of queue, can I use the same queue to print only right side? No, this node which are shadowed by the right side node. B is shadowed by C, D and E are shadowed by F. And if you see this over here, F is shadowing E and D, G is shadowing H, and J is shadowing I. So for that, I have used a queue, but instead of pushing left and right, as my requirement is the right node first, because it's a right side view, I'm pushing first C. And then now when I was understanding, I understood that I need extra hash map for this information. And then I also understood that I need this extra information for this hash map. Now one thing over here, everyone, as Pranav suggested, can we use extra information over here for its level? Let's say we can use it. Then this hash map is not required. Correct. Now if you see the way we are printing, in which way we are printing, first of all I pushed A, okay, for the level 0. Then for level 1, C and B are printed. Okay, so first I pushed printed for level 0, then I printed for level 1. Correct. Then B was for level 1, that's why I not printed it. Okay, now for F, the level 2 is there. For rest of the nodes, E, D and all, the level 2's node is already printed, so I'm not printing E and D. So now this information, do I have to keep it into hash or something else also I can store it?
So when we are saying we are not printing, so we are flushing the queue. So
yeah, we are flushing the queue because for E and D, they are shadowed by F. So that anyhow I don't need it because I need to print only A, C, F and G and J, because that is only will be visible from the right side.
Yeah.
So rest of the nodes I'm flushing from the queue. I'm processing that its children will be pushed into the queue. So like D is not printed, but its children H is printed or pushed into queue, because that might be position that H children or someone's children is getting printed. Right? So I'm processing in the sense I'm not printing, but its children will be pushed into the queue. So now my again same question to everyone. Can, instead of using hash map, can I use something else to represent which level I have printed?
What I was thinking is, Dhaval, for one level, okay.
Mm-hmm.
So we have 2 to the power n that label number of elements.
Okay.
So we keep on, if there is no element, then we have a space in the queue. So we know what level it is. So got me right?
Dhaval?
Sorry, can you come again?
Yeah. See, in the queue itself, let's say if it is the first level,
Okay.
zero is zero, right? 2 to
Zeroth
the
level.
power 0 is 1, right? So first element is in the queue is
A.
a. So second level is 1, right? 2 to the power 2. Second level is 1, but the number of elements are 2. So we keep 2 spaces. Even if, let's say, b is not there, okay,
Okay.
we keep a space empty. Let's say.
I,
So
I understood.
yeah.
So what will happen, what you are trying to say? So, okay, let me explain everyone what he's suggesting. Let me explain everyone. Let's understand if this tree is a full binary search tree. Oh, sorry, binary tree. Then what would have happened that up to all length, you should have all the nodes. Okay, and in which way you'll put it into the queue? Let me say you'll put it in the queue A, then C, then B. Okay, now D, E, -1 and F. Correct. So what will happen that A you have printed. So 2 to the power 0. So just one node you have printed. Now 2 to the power 1, two nodes should be there. And up to 2 node you will print first node only. So you have printed C as well. The rest of the nodes you will not print. So B you are not printing. Once the queue is empty, you should have 4 nodes. So you're keeping the space for 4 nodes. Exactly correct. But the first node which is coming into that you are printing. So sorry, it should be F because C is right side, it should be. So my bad that I have written a wrong queue. So at that time queue would be this. F -1 and ED. So for rest of the 4 nodes, I'm printing only F and rest of the 3 nodes will not get printed. And F's children, something like -1, -1. Then -1's children, -1, -1 will not get printed. D's children, E's children, sorry, E's children, first of all G and -1, and again these children -1 and H. So for rest of them, the first valid node you will print. So what will happen, because G is the first valid node, right? Not a -1. Because over here 2 to the power 0, over here 2 to the power 1, and over here for window 2 to the power 2, over here 2 to the power 3. So you're keeping the space for 2 to the power 3, but you are utilizing only space of 2. And also you need to find it out first valid node G. So that's why you will print G. So you are printing perfect A, C, F, and G, which is correct. That C is shadowing B, F is shadowing E, G is shadowing H, and for rest of the 2 to the power 4, you will print all of them. But what is the space complexity? You are using 2 to the power n, where n is a level, or 2 to the power h, where h is a height of a binary tree. That many space you are using, and that many time you are iterating, because -1 also you have to iterate, right, until you find the right node. So space complexity and time complexity is what? 2 to the power h, which is too high. It is not into log n, it is 2 to the h. Correct. It is not even into the order of n. It is 2 raised to h, which is very high. So that's why we'll not use it. But your approach was correct, and it was different.
Dhaval, why it is very high? Because when we say 2 raised to power n, we talk about n as all the nodes.
No,
It is
no,
just
no, 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 no. I have said h equal to height, because see,
yeah.
for third, so for height 0, we have one node. For height 2, we have, so for height 1, we have maximum 2 nodes.
Right.
For height 2, we have maximum 4 nodes, 2 to the power 4. For height 3, we have maximum 8 nodes, and for height 4, we have maximum 2 to the power 4, 16 nodes. So total is 16 plus 8 plus 16 plus 8 plus 4 plus 2 plus 1. Up to that many number of nodes will be required. So if you see, the total number of space which is required is actually in the level of 2 to the power h only, not the number of nodes. Correct.
can still be the case, right? Because if the input tree is like that, let's suppose it's a full binary tree, or
Yes, if it is a full binary tree, then the number of nodes are n. You have to process n nodes. Over here, number of nodes are not n. A number of nodes are not 2 raised to h. N is not equal to 2 raised to h. N is very less than 2 raised to h.
correct.
That's why this space is not required. If it is given 2 raised to h, if these both are same, then obviously order of n and orders to 2 raised to h equal to same only. But it is not given to us. And let's say the same approach which you are using, if in that way you go, what if the binary tree is not given, it is a ternary tree or 4 array tree? How many 2 raised to or 4 raised to h size you will use? Correct, which is very much useless. So the approach is very much correct. What I'm suggesting is approach is very much correct. But from that approach, we have to go back one more step. So from your approach, what I'm understanding is at level 1, only one node will be printed. At level 2, only one node will be printed. The rest of the node will not get printed. And as we are using queue, at level 2, I won't find any other nodes, right? So can I use, coming back to my previous question, can I use only one variable max level printed to process that which node is, which level is printed? Now let me explain how will I use it. Let's say in the same way I'm printing the queue. Only the thing is that let's say I have an information this A, B, C. Okay, in this way A, C, B, then F, E, D. And in this way, if I have information into the queue, so I have A level 0, B not B, C level 1, B level 1. Okay, rest of the nodes are F level 2, E level 2, D level 2, G level 3, and H level 3, J level 4, and I level 4. Now let's say max level printed is minus 99 or init minimum something. Okay, I'm processing it.
Yeah,
If
is it that we have a node which contains the level information as well, right?
let's say we have it. Let's say so. Pranav suggested, right, that if we have this, then we will not use this hash map, extra hash map. Correct. So I'm trying to understand that can I create such kind of information such that I don't have to use one hash map, and second hash map I'm removing from this, so that from order of 3n I'm removing to order of n only. Okay, so this is my approach. So let's say in a queue I'm pushing along with the node extra information level. So for A level 0, so if node's level is less than, so let's say initially it is 99 or init max. Okay, if node's level is less than max level printed, actually I'm still wrong. It should be integer min only, and it should be minus 99 only. Let me minus 99 and integer min. And if means node's level is greater than max level printed, I'll print it. Otherwise not. Okay, print the node. If this is my algorithm, A's level is 0. 0 is greater than max level printed, and yeah, max level equal to node's level. So initially my max level equal to minus 99. A's level is 0. 0 is greater than max level printed. Yes, print it. So A is printed. Max level is 0. Now in this, next node is C. C's level 1 is greater than max level printed. Yes, print it. C. Node level is 1. Next node is B. B's level 1 is greater than max level. No, don't do it. Remove from the queue. Next node F. F's level is greater than node level. Yes, print it. And max level equal to 2. Remove it. E, D, G, E and D will not get printed. They are not following this condition. They will remove from the queue. Okay. So yeah, after this, after this if line, I am writing that q dot q dot pop. So E, F, G, F, E and D will get removed, and B and C and A are also removed. Next turn comes to the G. G's level is greater than maximum level. Yes, print the G. Maximum level is 3. Remove it. H, 3. No, don't do it. Remove. J, yes, print it. Don't do other. 1. No, sorry, I. Don't do it. At the end, your output is A, C, F, G, H, which is required. So will this approach now will be useful?
Actually, how will we associate the digits with the alphabets, whatever we have, A to 0, C to...
Got it. Correct. So how can we do it? So let's say I'm writing like this. Okay, let's say I'm writing like this. So let's say I have a queue of node. Okay, and node structure I'm creating like this. Data, character data. Okay, node star left, node star right, and integer level. If it is permitted to me, will I have this information into this node itself? Now initially everything is, let's say, 0. Then how will I do it? Whenever I'll push it into the stack, push it into the queue, I'll print it. I'll push it something like this. When I'm pushing into the queue, q dot push nodes left. Okay, first of all, I'm pushing right. So q dot push nodes right. And before that, I'll write this condition. If nodes right is there, then nodes right's level plus plus, and the same way for left. Correct. So initially for A it will be 0. So for this code I'll pass A equals to 0. Now when I'll push C and B, I'll first increment its level and then push it into the queue. And same way for rest of the nodes. So then I'll have this information. So once queue is ready, I'll process the queue. Now, will this method be useful to me if given that this structure of node is given to you?
Yeah, that will help. Or else if this is not given, we can push we can create a custom.
Yes, then we can have the hash map.
Yeah.
Correct. Then we need to have the hash map. Or in a custom queue as well, either what we can say, either you can have a queue or you can have something else, queue's data structure as well, like a set. Instead of in a queue, you are pushing a set.
Yeah.
Set of node and integer. Correct. So two information you are putting.
A pair of node and integer.
Pair. Set in the sense pair you are putting. Correct.
Yeah.
Then it is fine. I think both the things, Java and C++ both support set. Right.
Yeah.
So then it is useful even if it is not given to you this way. Okay. But my point is, still it uses extra order of n space. Barabar? But rest of this we cannot do. Apart from order of n space, we cannot do. So can we think about writing the code of this?
Dhaval, this is Kapil. I did not understood this part where you're doing node write level plus plus. So what I understand is what we are trying to do here is we're trying to set the level part of data for all the nodes.
Yes.
So that we can use it in the previous
Yes.
So how this is actually setting this level for all the nodes? I'm not clear on that part.
So initially for A, the level is 0 when I'm getting it. Okay. For let's say all the nodes even, the level is 0. Is it clear first of all?
Yeah.
Right?
Yeah.
Now I started taking out this code. If nodes write, A has a write node. Yes, nodes writes level plus plus. So node A's write level is write node is C. C is level plus plus. So C's level will become what? 1, and I'll push it into the queue. In the same way, A's left side is B, and B's level I'll make it 1 and I'll push it into the queue. So I'll have up to this information.
Correct.
Right? Now, when I'm iterating C and B into Q, okay, the C node is having information what? Node's data equal to C, C's left is F, and C's right is null. So again, I'll iterate this into the queue. So this is just a pseudocode, kind of a pseudocode in the sense, kind of a code in which I'll use it. So for C, again, I'll do if nodes write, yes, node has a write F node. Then nodes write nodes level plus plus. Okay. It should not be plus plus, it should be plus equal to nodes level.
Current nodes level equal to
Plus equal to. So
what is this?
So nodes write is F. F's nodes level is 0. 0 plus equal to nodes level. So nodes level equal to what? 1 plus 1, 2 will happen. So yes, plus 1 also will have to do.
Yeah, so current node plus 1. Current
node plus 1. Yes, current node plus 1. I thought I'm again storing it into the child as well. That's why.
No problem.
Okay, so in this way, this will be done. Correct. Now, can we think about writing the code of this?
Yeah, I think we can write it as an assignment or maybe now.
Yes, we can think of it. Or what I was thinking is, let me write it, or whatever you think. Okay, let me write it down as well. Okay, full code. Let's write it down here. Okay, let's say I have an struct node. Okay, and in that, just for the sake of simplicity, I'm writing this kind of data. Character data and integer level. Okay, now let's have struct node star left star right. This part is clear. Now, whenever the new node is getting created, rest of the things will be null. That kind of method you will write. Now, void print right view. To that, first of all, what you will be passed root node. So node star root. First condition, if not root, return. First one is a basic condition. Now we'll start creating a queue. So queue of node star queue is my queue. Okay. Initially, I'm pushing directly my node root. Okay, and as I said, you will have this method in which you are writing, let's say, node star new node, in which if you pass character data or character X, not this one, it will write something like this: node star temp equal to new node. Simply new node is created, temp's data is equal to X, temp's level is equal to 0, and its left and right are null. Temps left equal to temps right equal to null. This kind of method, abstract method, you'll write. Now, once the queue is created, what we did is, until the queue is empty, we are following the process. So we'll write while queue is not empty, we have to process it. Queue is not empty, we have to process it. Now we forgot one thing, which was integer max level printed. So I'm writing just a max level, just max level printed. Okay, now I'm starting with the approach. Node star temp equal to q dot pop. So first node is popped out, which is A. Okay, and max level is, let's say, inter minimum.
So here we are using the approach of having a level in the node itself.
Yes, in the level in the node itself. Then I'll explain how can we remove that part as well.
Okay, so first we should be setting all these levels, and then
No, I'm not. No, I'm not setting any level. I'm just printing every level equal to 0. So when the tree will get created, every node's level is 0 only. In a tree, every node's level is 0. I'm not setting it up. If you want, you can set it up as well. When you are creating a tree, you can set it up as well. But let's say, for my sake, right now we don't have any level. Then how can we use? And then I'll optimize it further.
Yeah, understood. So I was saying that with the current situation where the level is 0 by default, we are not taking that as input. So, so first we should be using that queue approach to set all the levels, set the level for all the nodes, and then start the algorithm.
No. No. Our approach is something like this. I'll take it up A, and its level is greater than this maximum level. That's why I'll print the data A. Here itself, my algorithm will start to print the rightmost node. Now, which nodes to get pushed into the queue, that I'll push again in the queue. Now, until the queue is empty, it will get populated.
So in the same loop, we will set the level as well.
Yes, and we will print it as well.
Okay.
Yes. So nodes temp. Now, if the same thing, if temps level, correct? If temps level, is greater than max level, cout temps data. That means initially A is printed. Now my point will come if priority is to write. So if temps write is there, if temps write is there, then temps writes level equal to temps level plus 1, and into Q I'm pushing this node, Q dot push temps write. Now this is my first. Second thing, if temp has a left node, then only then I have to follow the next step, which are the similar. Temps left's level equal to temps level plus 1, and also into Q push temps left. Okay, which is part which I missed? This one. If temps level is greater than max level, see out temps data, and also max level equal to temps level. Now if I print this, if I run this command, this is while loop over, this is my main program over. Now if I run this, what will happen? Let's try run it. It will have the same. First, A node is pushed, its level is 0. Now until Q is empty, temp equal to A. If temps level, A's level is greater than max level, yes. See out temps data, max level is 0. Temp has an a write, yes, it has an a C. So with updated its level, temps writes level. So C's level I have updated to 1, and then I pushed it into the queue. So now it is into the queue, and then the next node B is into the queue. So after one iteration, my queue will be this. A is removed from the queue, C and B. Now I'll start iterating from the C. Correct? Because queue is not empty, the first part will be taken is temp equal to q dot pop. C is coming out. Temp's level, C's level is 1. 1 is greater than max level. Yes, max level so far was 0. So that's why it will print C, max level is 1. So in this way, the approach which we discussed will be continued, and it will print the level into this format. So this was the code for printing the queue right side. Oh, sorry, printing the tree from the right side. If we are visualizing the tree from the right side, which are the nodes which will be visible? So in this way we can print it. Correct? Now, what if we don't have this information into queue, which is like its level? Can I use this information at any point of time? It's just my thought. I have initially A. Okay, so first when I pushed A, I have only one node. So for rest of the nodes, I'll print only first node. Now when A is removed, okay, see that A is removed and C and B are pushed into the queue. Then for rest of the two nodes, my first node will only be my output. So A is my output, C is output. Okay, now for rest of the two nodes means for B as well, my output will be C. That I can do with some for loop. Correct? Now C and B, its node, I'll put it afterwards. So C I'm processing, okay, C I'm processing, and then and only then I'm pushing its data into the queue. I think I can use it, this information. Think about it. This part you can try it out into the assignment. I think I have given enough hint for this, but you can try it out. So at any
Can
point
you
of, yes,
can you repeat this what you just said? I didn't understand.
yes. So what I'm doing is, let's say I'm taking a size. So let's say size equal to q dot size. Okay.
Okay.
So initially q size is what? 1. Everyone,
Yeah.
please see over here. So q size is what? 1. Now for I equal to 1 to I less than size, what I'll do, I plus plus until that time only. Okay. Until that time only, I'll take it out the node from the queue. So let's say I'm putting over here B and C. Okay. So for the first time only, I'll print C. Just see over here, I'm not exactly writing the code. For first time only, I'm printing C. For rest of the time, okay, I'm not printing anything. So initially A is printed, then C will be printed, and C's children I'm pushing into the queue, but they will be not into for loop. C's children is F, and let's say B's children are, what are they? D and E. D and E will be pushed into the queue, but only as the while loop for this, oh sorry, for loop was this for 2, initially for 1, and then for 2 was that I'll print only C, and B will be just like that popped out and pushed it into the queue. Now what will happen again? When the size is equal to Q size, what is the size Q? 3. Again for the first element F, I'm printing it. For rest of the nodes, I'll just push it into the queue. So whenever my I is equal to 1, for that only I'm printing it. For rest of the nodes, I'm not doing anything. And that too up till size only. So even if I'm pushing the rest of the nodes over here, let's say F's children are no 1, but E's children are G and H. So even if I'm pushing the node over here, G and H, this for loop will not hamper this, because it is going until the size 3 only. So F, D and E will get only removed from the queue. So that logic you have to write over here. And for I equal to 1 only, you can print it. Now, are you getting my hint? Yeah. I'm actually giving a whole solution. It's just that I'm not writing the code.
Yeah.
Then even if the node doesn't have level information, you can print it. Correct. Okay. Even if the node doesn't have the level information, you are storing into the hash map, storing into the size of the queue, that this size of a queue has 2 elements. That means right now the level is 2.
2. Yeah.
Then it is 3. That means level is even 3 or 4. But the first element into that should only get printed. For rest of the 3 nodes or rest of the 2 nodes after that, it should not print. It's just pushed into the queue. Then rest of the 3 nodes again, we need to process it further. So you don't need level information at all, or not even a node. So you guys can try. Yeah.
Here we are pushing all the nodes in the queue first.
Yes.
Already.
Yes. So when I'm processing F is printed because I is equal to 1. I printed or pushed F's children into Q, G and H, let's say. And then D's children, I and J also into children, and E's children also. But for D and E, I'll not print it because I is not equal to 1. It's just its information I'm pushing. And then G. Print it and then process further. So just if I write in a pseudocode, for I equals to 1, print it. For rest, I, just push it. And for this also print and push its data, push its children. And for rest of I, push its children only. Simple. Now have I made it completely simple?
Yeah.
Yeah. So everyone, please note down this approach in which we have written this very useful code that I'm asking you to write it down into the assignment. This is the second code which I'm writing, asking you guys to write it down in assignment. And this is the exactly same code into C++, which we can write it down. Correct? Okay.
Yeah.
Any doubt? Or you guys need it's this code into IDEO1? What I'll do
We
this.
will
Yes.
try, and then if we have any issues, then we
Sorry.
can write.
Yeah.
We will
Yeah.
try it. We'll try it, and if there is
Okay.
any issue we are facing, then because you have
Okay.
already written the code, like pseudo code, right?
Yeah, actually it's a working code only. I have not written
Yeah.
integer main. But what I'll do, I'll convert this code into written working code into IDEO1, and I'll give it to you guys tomorrow. Okay, this part. Okay, and by that time you can think how can you write it down this code. Actually, I have given you the full logic. Okay, so these two questions are into assignments, and now in next lecture we'll see this part of a question. Let me check. Without q, print right side of a tree, then left side completely. I'll give it into the assignment, all the codes. So let's say without q and with q, this one, and possibly after that top view or vertical sum, both are the similar one. That we will do into the next class. Along with that, few of the other questions also I'll take it up. Let's say uh, some k sum path equals to, so there are so many questions. K sum path, diameter of a tree.
There's also one question where we need to add pointers in a level, like we need to traverse.
Exactly in which way?
Like suppose, can you draw a tree? Just example, you have this.
A, B, C, D, E, F, and G. Now,
So we will have like in that question we will have pointers from B to C, D to E, E to F, and F to G, like that. So
so
we
we
need
have to
to,
convert a tree into this one.
yeah, like that. We need to add pointers. Like that.
Now it is simple as that. Can you do it
Yeah,
now?
yeah, yeah. We can do that.
Yes, actually, with the level order traversal A, then B, C, then D, E, F, G, you can do it, right? You
Yeah,
can
yeah,
have
we
an
can do
extra
that.
pointer temp, which is your previous node. But yeah, you need to keep track of first node into its level,
Yeah,
right? The first node is A. Now in this level, first node is B. Now in this level, first node is C, whatever, D. Then D's next is next node E into Q. E's next node is F, and F's next node is, or whatever this pointer you say random, it is into this. It's very good question which uses this information level. If C is equal to 1, instead of this format, you may have to use this kind of queue. A for level 1, for level 2 B and C, for level 3. So from new first node into this level, just like this two will be joined, and in this D, E, and F. So D, E in E to F will get joined, not C to D. Correct. So this will use this information and this queue as well. Isn't it similar? Few tweaks you need to do into your logic, but what we can say, the heart of the essence of the question, this question's essence is this only. Correct.
yeah,
Okay, what I'll do, I'll take it out this question next time. You guys, everyone can think about it. This is a good question, but it has a similar of this, very similar to this. Here I'm just printing it, the first node, Instead of that, you need to create a pointer from this to its next node. Correct?
Yeah.
As simple as that. We'll take it up, no issues. Very fast we'll take it up. If you guys have done this code in next class, then we'll take it up. Okay, there are so many questions as it say diameter of a tree, convert a tree to forest. There are so many questions. I'll take it up maybe approximately for 4 to 5 classes. We'll take the tree only, because there are very many questions into the tree. List common ancestor, correct? There are so many questions. Mirror of a tree. Then we have
Yeah, Dhawan, what I was thinking is if you can put a list of all the questions
no.
related to each of the topics.
No, no, no,
Uh,
no, no.
Not even now. Maybe later we can
So
try those out. Have a
yeah,
note.
once, yeah, I understood. What I was thinking is I'll keep the questions which I explained. Okay, but which I'm going to explain, that I'll not keep it. Why? Because let's say I wanted to give this example. Let's say, just for the sake of example, let's say k distance node. I want to give it into the assignment. You will have it from the prior information only. That I don't want to do. Maybe I can explain it. Maybe I can give it into the assignment itself. That's why. And maybe some new questions also I am keep on finding out. Just say the pronounce it this question. Then we suddenly come up that, okay, this can be the solution. Someone asks new question. I have to explain the solution, that we will take it up. So question can be impromptu, no issues about that. But these are few questions which will cover all the kind of logic which can be there into tree. As this was one of the logic. In that way, there can be so many logic. The hard, or I can say the what we can say, essence of the tree will be same, recursion or iteratively printing it. But what other type of logic we can use, that we'll see into these questions. Okay, so these are the few questions. Apart from that, there are many more. We'll discuss into the trees classes next time. Till that time, just convert this part into code. This part is already there. Even if you don't do it, it's fine. This part, and I'll this part's code, I'll give it to you tomorrow. But the previous question that I think I have discussed, which one was that? Printing into zigzag, that you guys can try it out. So for today, the assignment is just this one, zigzag code, which we discussed. That is one. And second is right view without nodes level information. Without nodes level information. Correct? So we'll meet next is Friday, right? Yes. So we'll meet Friday 22nd. So till 22nd. Have a nice days, guys.
Okay.
Thanks, Dhawan.
Do we cover matrix problem also? Matrix problems?
Yes. After tree, try, range minimum query, we'll take backtracking, in which metrics will be taken up.
Okay, sure.
And how
Sure.
about searching sorting?
Yes. Someone has a question.
Yeah, how about searching sorting algorithms?
So I think I have given everyone. So those who are online, I think I have given the part. So after tree, as I said, try, range minimum query, backtracking. So backtracking, it will cover, so tree try means binary search tree and all that thing. Backtracking will cover 2D matrix. Then dynamic programming will be covered. Once dynamic programming is over, then searching. So searching is just binary search will be taken, because there is only one method. Sorting. So in sorting, quick sort. Then Dutch Netherlands problem. That kind of few questions will be taken. Merge sort are easy. Quick sort is little bit good one. So that's why I'll take the quick sort and Dutch Netherlands problem. Apart from that, rest of the algorithmic method like divide and conquer, greedy, all of those will be taken after this. And once this part is over, almost all of your course is over, then we'll take up the graph. So in graph, pseudocode with the logic, and because in graph people are not asking many interview questions, that's why we'll cover up less questions, but whichever the parts are required, that I'll require, and then system design. So this would be your course. I think I covered pretty much everything. Sure.
Yeah. Thank
Okay.
you.
Yeah, yeah. Thank you, Dev.
Thanks. Good night. Good night,
Thank
guys.
you. Good night.
Yeah, good night.